The second video attached to the September 25th remote session. It will be a relatively short one, but it's intended to build off a point I brought up when introducing graduated symbology for points. And I introduced it with points, but this would apply to any symbology that is using graduated numerical values. So this could be for a point, a line, or a polygon. The point is, when I pick a field like price, or temperature, or population, or number of crimes, right, or anything you want to depict that is numerical in nature, that is linear in nature, that has a bottom, a top, where 10 is 2 times more than 5, you need to pick a method of breaking, right? You will control the number of breaks. So I could come here and say 4, right? And it would use this method called natural breaks to actually break that value. To say the 4 values go like this, right? 246K, 355K, 518K, and 1.2. You should really be asking yourself, who defined those breaks and why? And this is where it's important, I think, to one, come quickly to this histogram, because I want to show you what a histogram really is here and why it's important. I'm going to take statistics away and go to method. What this means is, what is the mathematical operation being chosen to pick these values? And it's often easiest to understand if I go to the first one, which is equal interval. What equal interval does, and it may be easier for you and me and others to wrap our heads around, is it just takes a value of 300,000. So it says anything 0 to 300,000 is boom. 300,000, 600,000 is boom. 600,000 to 900,000 is boom. 900,000 and above is bam. But the problem with that is what we're seeing here are a histogram. And what a histogram does is, on this axis here, it is showing you the potential values. In this instance, the potential price of a home sale. But that could be anything you're mapping. It could be the population of something, the intensity of something, the distance, whatever. And this is plotting, even though you can't physically see the axis telling you number, it's plotting the number of records. In this instance, the number of home sales. So what we can see here, and if I get statistics up, I'll even get more, we can see that there are 460 home sales. The lowest we have in our database is 0. The highest, I filtered out those outliers, is 1.2 million. The mean is 335,000 right here. So what that would be saying here is that this value, 300,000 and under, is probably accounting for roughly 40 or so % of our values. Then this next one, 300 to 600, that's got almost everything else, right? That's another 40 or 50. Then you have this 600 to 900,000 that has sort of a pittance, and then you have 900,000 and above, which has, 2, 3, or 4 home sales. So even though it's logical to us, because the difference in the value is even, the number of records, the number of home sale prices in each bucket is not equal. That's the difference between quantile and natural breaks, which actually takes a very different approach. The values change dramatically here, right? You have this big jump from 0 to 269,000, then a teensy jump from 269 to 325, then a bigger one or a teensy one from 325 to 3850, and then finally a huge jump, right, from 3,850 all the way up to 1,200. What's true of these breaks, though, is that from 0 to 2.7 or 270,000, there's the same number of home sales as between this, as between that, as between that. It's like back when you took your GREs or your SATs. A score would come back to say you're in the Xth percentile, right? If I were to do 5, it would literally mean that between each of these breaks is 1/5 of the values, 1/5 of the home sales. So I would say anything above 400,000 would be in the upper 5th, right? Anything below 250,000 would be in sort of the lower 5th. And I probably should factor out 0, but I'm too lazy to be able to do that. That's what quantile is getting at. That's why quantile and natural breaks are what you should refer to most commonly. But this is manual too, right? You may have some data sets that you know really well, like perhaps what you want to be able to visualize here are homes that are maybe below 300,000, because maybe you know that's the median home sale. I'm just making this shit up here, but maybe you know that's the median home sale for Prince George's County, where this is. And then this one here would jump to 550,000. And I'm making that one up too, but my point with, what happened? 550, here, 550. And maybe what 550 represents is the median home sale of the DC Metro. And then I could label it that way, right? I could say homes are less than 300K, median of PG County. Less than 550K. Again, I'm making this up, median of DC Metro. And then anything else would be greater than 550K. So I could say greater than 550K. Maybe I'll even come in here and add some sort of color to these. You know, it's red. Maybe this is orange or green. I'm just making some crazy nonsense up here. And this is like a blue. But the difference here that you should feel comfortable doing is when you don't need to equalize the population, right? When you don't need to use quantiles to ensure that you're making natural breaks that are empirically sound, so that the number of records, in this instance home sales, is equal between your values. If you instead know what the values should be because you're trying to connect with your audience and compare, you should absolutely change them, right? Because this might have meaning for an audience I'm working with. They might be really quickly able to see that College Park, definitely the homes are a bit higher here than PG County in general, because we don't have too many of those, right? But a great number of homes here do tend to fall in that in between PG County and DC Metro. And only sort of a cluster really right down here in the center in these nice neighborhoods tend to exceed that 550,000, which is our made-up sort of average for the DC Metro. So that's what I wanted to talk to you about here with method and class when we're breaking graduated symbols. And the same thing we talk about here can apply to any kind of symbology, whether it is point, line, or polygon.